our instructor for today, and that is Larry Waters. Take it away.
All right. And quick thumb up if you can hear me.
Yes,
All
sound great.
right. Good, good. All right. Well, welcome everybody. Thank you for coming in into the day. Um, guess you didn't have anything better to do on a Thursday or what day is it? Tuesday afternoon. But welcome. My name is Larry Waters. If you haven't been on one of my classes before, hopefully you will like it. We're going to talk today. We got our ooh safety message out of the way. We're going to talk about the overview of Electrify Efficiently. Um, okay, making sure we're on the right slide deck here. Electrify Efficiently webinar series. We talked about a little bit of the product manufacturer disclaimer, the electric options for HVAC and water heating, and some other cool electric stuff you may or may not know about. We'll get into the details here. Feel free to ask questions. Just put the questions in the chat. Alex will be answering some of them, and then we'll have a few minutes left at the end for answering some questions. So, who is the guy you're listening to here? I got the filters turned up pretty good, so maybe you can't tell I look this old, but um, in 1982, I went to Universal Technical Institute for heating, air conditioning, refrigeration, and at the time they called it solar, but it was just how to warm up a pool with water going through tubes. Wasn't really any PV going on then. And at that time, I was using real duct tape for ductwork, which we don't use that for that anymore. We figured out that was a bad idea. I don't know how many bad connections I'm responsible for, but sure it was a few. And my first drill had a cord on it. So I was really excited when the first cordless drill came out. I was like, wow, look at that thing. One of those big ones with a long battery on it. Um, so I've been around a minute. I am a NATE certified service technician. I have been for 24 years or so. We keep renewing that thing every couple of years. And then also a BPI certified building analyst. And I've really gotten deep into the weeds on that. If you don't know what BPI is the certification program, basically with the curriculum and certification for understanding how houses work. Not every good home performance guy is BPI, and not every BPI is a good home performance guy. But it's a good way to tell if you're talking to somebody that at least understands the basics about home energy science and how everything works as one system in your house. In 2015, because of BPI, they teach you how to make houses theoretically smaller so that we can put perfectly sized, fit like a glove systems in. And so we learned the part about making houses smaller, but the company I was at the time, we were still selling a lot of gas, and we couldn't find gas furnaces that were small enough because we were making the houses really tight. And so I started dabbling in these things called inverter heat pump systems. And by 2015, I told my boss at the time, I says, I'm not selling furnaces anymore. And he says, come on, dude, just go sell a furnace or two. And I'm like, I can't. The Kool-Aid had the perfect level of sugar, and I drank a lot of it, and I could not go back. A lot of BPI guys went through and got certified for a program that was kind of happening at that time and kind of went back to the other way, but I wasn't able to do that. So got to consult with the state, was on the board of the Decarbonization Coalition, kind of got my name out there. And I says, I'm going to start my own company in 2020. So I really started this thing like a month and a half before the COVID lockdown. So that was an interesting time. But it all worked out and things are good. Company's growing and up to 19 employees now. So we're doing good down here. Just installing electrification for residential remodels or residential retrofit. Um, and the only thing we do with gas lines is put caps on them. So that's a fun thing to say. Okay, so today we got this one. The next one is going to be optimizing heat pump zoning for maximum comfort and efficiency. That's a really good training. We're going to bring in a lot of information about different options and how it all works. So looking forward to that one coming up in about a month. This is our company's mission statement. I always share this with even every customer. We do all of our customer consultations virtually. So it's good for your customers to know what your mission is. And so if you're in a business and you don't have a mission statement yet, I would implore you to do that. It's one of the things we help our guys with in some of our training classes. But our mission is to provide the most efficient, cost-effective solutions, and that doesn't mean the cheapest heat pump, but it means the heat pump that's going to use least amount of energy over time. We practice this crazy thing called good stewardship of the electrical panel, and what that means is that we don't put a bunch of circuits into electric systems that don't need to be there. We put low energy appliances in, and we help our customers potentially electrify everything in their house on 100 amps. And that sounds weird to some people, but it can be done. We've done hundreds of them that way. And then down on the bottom, that's what this is. So before we get started, I just want to give you a little disclaimer. The products and the brands shown here are not something that we're telling you should buy brand only, but are just examples of potential electrification solutions. And so we don't endorse, recommend, favor, or receive payment from any of the product manufacturers or distributors, for example, shown here. Okay. So we can't do electrification without heat pumps, right? And we got to do heat pumps right so that they don't cause problems. But so just a little bit of history. Um, Furnaces really haven't changed that much in 150 years. We're basically still burning things to get heat into our house. We're doing it a little bit more efficiently than we ever were before. Obviously, this monster on the side over here, which is actually not technically a gas furnace, but it looked really old, or these units are a long way from one of these nice 95% efficient condensing furnaces. But still, we're burning gas and blowing the air around is the way we've been doing it for 150 years. And so, what heat pumps represent to me is a massive technological change in the way we're going to live in our homes. No different than when we went from our tube TV to our flat screen TV or our flip phone to our smartphone. We didn't have a lot of resistance on those things. So, we shouldn't have resistance to getting that technology in our homes. Um, there's really no reason why you would want to be on gas anymore, especially with the technology that we have now. So it's 150 years old, time to get it out. Everything's evolving out there, right? We went from at one point there was a point that if you went to New York City, all you saw was horse-drawn carriages, and then you saw a lot of horseless carriages, and then we saw big, beautiful automobiles from the 60s and 70s and 50s and whenever. And then we've got a little sleeker and a little more energy efficient all the way up to the point where, we're running on electricity. You can't go to a stoplight without seeing a bunch of electric cars now. So the technology itself is pretty amazing. If you've ever driven an electric car, it's a little bit of a different experience than driving in a gas car. And so having an electric house is kind of a mirror of that experience. So HVAC is evolving. We now have technology that we can put into our homes to heat and cool efficiently that are just as modern as the new modern electric cars. So also, if you electrify your house, value goes up. You buy any kind of car, value goes down. So electrify your house first. It makes more sense. Okay. So there's a couple different outdoor unit classifications. We have the unitary systems that come in both single, two-speed, and then some sort of inverter options. And then we have what we use all the time is mini split platform stuff. The split platform stuff is number one, more affordable than some of the other inverter technology that's on the unitary level. But also we can do so much more with it. So we just love them. They're easy to install. They're super to fit in anywhere. And as you can see, they make really, really happy customers. Here's a couple of different indoor unit classifications. We've got our basement installed system, properly sized return air. You'll notice an ongoing theme. We use the same exact filter on every single system we install. We adapt the sheet metal in the system to fit the filter so that I only have to carry one filter in my warehouse. That's been a game changer. But a lot of different configurations with this technology, and this is all mini split based technology. Right down to even our horizontal ducted system with our custom plenums and our filtration put in there. This is one of my early conquests that I did a long time ago. Wasn't able to put a April air filter on that, but lots of different ways to do this with the slim stuff, and that's pretty clean work, you got to admit. Slim duct options, or what we call mid-static units, are what the thing is. And there's a different, if we talk about slim ducts, some people are going to think of the old units that didn't have much pressure to push air, that were really complicated to install properly because you had to be really careful. And now we have the Americanized version, which allows you to be a little less careful, but you still need to be careful. Um, but these systems can fit in a lot of spaces that we couldn't get systems in before, like flat roof houses with higher ceiling hallways. We can just tuck the thing right up there, drywall in over it, and it's a beautiful thing, becomes part of the house. Put a couple of return air grills here so we have access to get in it and out of the unit. Here's another one. This unit here is actually installed in the sheet metal box, and that box is the return air plenum. And then we have our filter grills there that allow access to service the unit and have the filters in a nice, easy spot. A lot of ductless stuff going on out there. There's lots of this that's been around for a while. We see these all over Europe and Asia, now all over the United States as well. As a matter of fact, in some countries, you can buy these in a liquor store. So you can go down and pick up a fifth of bourbon and a new mini split for your house. Can't can't imagine a better life than that. These come in a lot of different types. We have the lower floor, what we call a floor mount model. These can mount all the way down to the floor, or be installed low wall like a radiator. Our single direction ceiling cassettes, more and more of the manufacturers are building these, so it's one small unit in one end of the room, and we blow the air across the room just like we would a ductless mini split. And then we have the four angle solution that we can put in the middle of a room, and we can get air going whichever way we want, and we can make the air go out where we want it to. So lots of options around that. Why do we use this type of equipment? Traditional heat pumps were great if you could only have a heat pump. But since we need to replace gas furnaces with heat pumps, we need to be really careful about it. And we need to be very deliberate about it. And we need to design them to fit the houses properly for best application and lowest energy use. Traditional heat pumps, if we put them in, the most traditional heat pumps just turn on and off. There are some that have a high, low, and off, and that's a little better. But still, we're dealing with a machine that turns on, does its job, shuts off, and lets the house dictate what's going on. We want to dictate what's going on in the house instead of the house dictating what our system is doing. These systems are typically using a lot of energy every time they start. And if we want to size one of these to where it has enough capacity when it's cold outside, then it's going to be too big for all the mild days of the year. And we do need to size. We're not going to have happy customers if we size a system for the mild weather, and it doesn't work when it gets hot or cold. So, and I know you guys are over in the Tri-County area, getting cold. Um, Heating a house is way more important than cooling the house. Not as many people have cooling over there. Um, but these traditional compressor systems, they kind of don't spend a lot of time at the comfort zone. They spend a little bit of time either a little cooler or a little warmer than the comfort zone. And there is situations where, as it's getting really cold outside really fast, this type of system can shut off. And then by the time it cycles back up again, the loads are too low and it can't heat the house anymore. So we don't use these at all. We only use inverter driven systems. And there's a bunch of different types of inverter different systems. Well, there's a bunch of different brands, and they all do it a little bit differently. And then there's a couple of different types that are important to know about. But what we do is we design our houses for the benefit of this end part down here. So a typical cycle, we'll just look at air conditioning because that's what this graph shows. You walk into your house and it's 80 degrees. The whole house got to be 80 degrees because it got warm outside. And so everything is the same temperature because it got there nice and slow. And your couch and your walls and everything is 80. You come in, you want it to be 75. Some inverter systems are going to notice the temperature difference on the thermostat, and they're going to start off really slow using very little energy, and then they ramp up to take care of the temperature difference pretty quickly. And instead of overshooting and turning off and letting the house glide back up or down, these systems actually narrow down when the air gets to the temperature the thermostat's looking for. this machine still knows I have to load the furniture, or I have to remove the heat from the thermal mass. And so it goes into this point we call tempering, and it makes small adjustments in its capacity as the furniture is accepting the heat or giving off the heat, depending on what season it is. And then we get down to the point where everything in the room is now mechanically altered to be thermal equilibrium. So everything in the house is the same temperature. Then the properly sized system can actually go down into its lowest mode, and it can maintain the temperature in the house using a tiny bit of energy. And last year, our average size system was just under, if we took all the systems we put in a year and we looked at the average BTUs, and the average BTUs was just under 24,000. So we put in pretty small systems, even in big houses. So typically our systems right in here are going to use a couple thousand watts or 2 kilowatts. Down here, we might be using as much energy as, 5 or 6 old school light bulbs. So to be able to maintain the temperature in the house at such a low rate of energy compared to the getting the house warm and cold, when you install the right heat pump system and customers leave them on, it costs less to leave them on than it does to heat or cool them down again. So generally, most of our systems will run for about 5 to 6 hours here at thermal equilibrium for every 1 hour of trying to recover temperature. So here's the differences in the two inverters that are out there in the biggest play. And I don't know, maybe some of you guys know, there's a company called Bosch, builds a really nice little heat pump, and it's an inverter, and they'll talk about it as like it's a fully modulating inverter. And it is to a point, but it's a temperature sensing pressure based inverter. In other words, there's no control other than a sensor that senses the refrigerant temperature that's causing that thing to speed up and slow down. And when those type of systems get installed in a house that has poor airflow, or that part is not dealt with properly during the design of the system, um, they can sometimes not ever go into high speed. You can have problems with them. The fully modulating and communicating inverters, on the other hand, they're going to have the thermostats that are going to know that temperature difference and be able to speed the system right up. So if you come back from a run and you're all sweaty and your house is 78 and you put it down to 75, it's going to recognize you did that. It's going to speed the machine up. It's going to get down to 73, and then it's going to slow back down again. So this is also available in some very high-end unitary equipment, but we can do the same thing with equipment that's much less expensive. So efficiencies on these are going to be based on normal rated outputs. And what that means is they have to test this equipment somehow and rank it against other HVAC equipment. So they do that in laboratory conditions under certain temperature and humidities. And by doing that, it gives them an even playing field for giving it that SEER rating and that EER rating and that HSPF rating. But the thing about inverter technology is it can go faster than design, and they can go much slower than design. When they're going faster than the design, they might be using a little bit more energy than they're rated for in the lab. But anytime they're moving slower than nominal rated output, they're always operating more efficiently. So when we get our houses sized right and we're using these systems to keep the house at thermal equilibrium, my SEER ratings and my EER ratings, they go through the roof. Okay. For controllers, most of these units are going to have their own manufactured communicating controllers. It's always best to install these with the manufacturer communicating controllers, because that's going to be the one that's going to have the same communication protocol with the outdoor unit. And we're not faking it out trying to think that it's going to do what it needs to do. The reason I say that is because most of these manufacturers have a low voltage kit that you could put on there, so you can run a traditional thermostat off of it. But traditional thermostats they only sense the temperature and they turn on and off. It's like a wall switch with a thermometer built into it. The manufacturer communicating controllers can adapt the capacity of the system based on small increments of 1 degree. So some of them can use the traditional on and off thermostats if we install that module in there, but we're kind of chopping its efficiency off at the knees. Control features. The control feature on this, it adjusts output based on control setting, and the temperature pressure sensing system doesn't do that. It will not respond to T-stat changes in real time. Compressor speed on these is up to 700 points of complete modulation, so it's a curve. And these most of these systems are 5-stage inverters, so they do have multiple stages there, but it's going to be based on the temperature of the refrigerant in the coils, and that's going to be based on how much air I'm getting across. So what we see on this type of system, when the filters get really dirty, they stop not wanting to perform at full output, because the refrigerant temperature is not at the right levels to alternate the compressor speeds. Most of these units on this side have no fixed airspeed. They do have fixed airspeeds you can adjust to, but when you put it in auto mode, it will adjust up and down with the compressor. And most of these type of systems have a fixed blower speed. So even when your unit is operating at max capacity, or it's moved down and it's down operating at the lowest capacity, it's still moving the exact same amount of air through the system. All components communicate here, and no components communicate here. Some of the newer systems have a little bit of communication between indoor and outdoor, but not with the thermostat. And then these units over here, we typically use systems that we run one power line to the outdoor unit, and that powers the indoor unit. So there's only 2 breaker spaces needed. All of these systems are going to require some sort of an additional circuit for the air handler, whether it be 115 or 220 volts. It's just going to depend on what system you're installing. And beware on those systems with the 120-volt air handlers that are not application or manufacturer specific. They don't all have the greatest of AHRI ratings. An AHRI rating is the American Heating and Refrigerant Institute. They're the ones that do the lab testing and verify the capacities and efficiencies and all that. Some of the modulating inverting systems will run from 130% all the way down to 20%. These are never going to be over 100%. 100% is going to be at the top, and they're going to stage down. So if you're putting in a 36,000 BTU unit here, you're going to get 36 or a little bit less as the peak. If I put it at 36 here, I might be getting 45,000 BTUs out of the machine when it's fully ramped. So we can do so much more with the fully modulating communicating inverters than we can do with the temperature-based systems as well. Okay. So the advantages of mini split inverters is large range of operating capacity, like we just talked about. They're small. They only have to be 20 inches off the wall. Most of these units are about 12 inches deep here in the top part of the shoebox, and they only need to be 6 inches from the wall. So you can put one of these in a place where there's a pathway going down the side of the house, or we have the restrictions in certain cities where we can only be so close to the property line. These are a great solution for that. These do have horizontal discharge, so whatever small amount of sound that is on there is being transmitted out horizontally instead of up vertically into your ears. Low static pressure models for small applications, like we have these that are very small, a little harder to get now. And then the mid-static products can do more air pressure than a typical furnace can do. So we can do a lot with these if we design them properly, or at least design them pretty well. So why a mini split heat pump, ducted versus ductless? So the ductless advantages is, like in this picture, this is a 120 volt ductless unit. I put it in these people's room. They only use this when the power goes out and their house is running off the generator, but it's a great option for that. And because these systems are very small, they get really good efficiencies because they're just tiny, right? But they're so tiny, some of them, that you're not going to notice how much energy they're using anyway. So lots of configurations and styles. Great for 1 to 3 rooms with multi-zone. My recommendation would never be to go over 3 rooms with a single multi-zone outdoor unit. So if you have a house that needs 6 of them, you should be using at least 2 outdoor units. The ductless disadvantages is we really need to put these on outside walls, because when you're running them in cooling mode, water doesn't need to get out of there. I can add a little pump to these, but when I do, it's just another thing to go out. They're not as easy to service. Pulling these things apart and trying to get in there and clean them is really difficult. These are not an easy sell for people that are aesthetically have an aesthetic eye. And then these are not very good for air quality, because the filter in them is like the dryer lint screen that you have to clean. except for a lot of the dirt gets right past it and it gets impacts on the blower wheels pretty easily. And that can be a cleaning, I won't say a nightmare, but it's a bit of a project. So in those cases where the customer says, and that's not going on my wall, there are some solutions out there. There's what's a glorified contact paper. I'm old enough to remember when you could go down to the five and dime and you could pick up rolls of contact paper and you could just stick them to stuff so you could make anything in your house look like it was real wood. So that was actually a time for you younger people. LG makes this cool one. It looks like an art frame and you just slide your own piece of art up in there and it's doing the cooling from behind there. These are only available in multi-zone. I found out the other about a year ago. And then there's a company that makes these wooden covers. Um, but I mean, if you would rather have that over that, I mean, it's cool. They have them. This is a company called Quilt. Let's let you enjoy this great little video. Um, there's companies out there starting and starting to solve this problem. As a matter of fact, we just became a quilt dealer. This unit is much more narrow and more aesthetically pleasing. It has a built-in backlight, so it looks like something that should be on the wall, and it kind of looks like a big wall sconce. And since it's got the light built into it, it is actually a wall sconce that cools your house and heats your house. So that's pretty neat. You can also do the ceiling mounted cassettes, or what we do, just go ducted. Use the mini split technology in the various forms that we have for fully ducted systems and just hide everything but the little vents that people are used to living with, right? So some people would be okay with this, but there's other people that are going to go, I don't know if I want that on my ceiling. But if you're working in a really modern home like this, people might be okay with it. But if we do ducted, we keep everything away. I could do multiple rooms with one system. They're just amazing. Multi-zone options out there. We've got units out there now that can do one outdoor unit and they can do 10 indoor units. They use these branch boxes, and these branch boxes can feed other branch boxes, and we can have like this whole system in the house. But remember, you have to run wires to all of these and you have to run pipes to all these. So there's a lot of stuff gets hung on the walls on the outside of the house, and it can make everything just kind of look kind of weird. So I try to talk customers out of these when they've said that they've talked to somebody that put them in. We find a lot of companies put these in because they're maybe just not comfortable enough to do the ducted model here, because you got to be a little bit careful with it. And putting in one system in a room, or for one system in an attic for multiple rooms or a whole house that is going to be the same size as if I put a few of these in is a much bigger difference in the amount of cost for the job. Okay. So what are the advantages to multi-zones? They do have flexibility for multi-room solutions, but people get sold these wrong all the time. So these systems, if we have a bunch of them, we have to add the capacity of all the units we're installing and match it to the capacity of the outdoor unit. Dakin's a pretty good one because they'll go 130%. In other words, you can have 130% of load in the house compared to the outdoor unit, which is a good thing, but it suffers when you want to use them all. Less space is needed, particularly if you don't have a crawl space or you don't have an attic space. These are great solutions. It's really the only time we use anything like this. A lot of times we'll do a ducted system with a separate, in a multi-zone with a separate unit for like that troublesome room over the garage or that basement room where it's a little bit of a different climate zone. But make sure you tell your customers you can't run heating and cooling at the same time. The disadvantages to these, all these things have to be connected with piping. And as you saw in the picture before, some of these brands have this branch box and you feed this unit into the branch box and then everything goes to here. The downside to that is we got to figure out how to get the pipes everywhere, right? Most people aren't going to say, okay, you can just tear apart my walls and run pipes in. So we end up having to put things on the outside of the house. And if you're talking to somebody that has a beautiful home and they have an aesthetic eye, you really got to be clear about what you're going to put on their outside walls. Otherwise, when they come home from work and see all that stuff on there, they're going to get upset. And I know that from experience. More chance for leaks. Every one of these has two pipes going to it. And then the other end of those pipes has to hook up somewhere. So just in these three on these ends, that's 6 potential locations for leaks. And those pipes have to land somewhere else, which is 6 more locations for leaks. I got 2 more. This is 8 more locations for leaks. I've really now got 20 potential places where refrigerant could leak out. And because I have to get refrigerant to all of these, they hold a lot of it. So we always have to add refrigerant in these systems, and if there's ever a leak, there's going to be a lot more damage to the environment than if we just had one set of pipes. The capacity penalty. So the capacity penalty thing is if I have to add all these up and say I got 3 small bedrooms and I got a living room and I got a kitchen family room. And so to get the smallest one of these, I'm still going to mostly be at least 50% over what my load calc calls for. Most of the time, 100% over. The smaller applications of these is 6,000 BTUs, and most rooms that we calculate out don't need any more than 2,500 BTUs. So 6,000 versus 2,500 means if I want to run one of these units, it's never going to slow down. It's always going to blow really hot air and really cold air. It's not going to have the opportunity to temper the space and get down into thermal equilibrium unless I run multiple at the same time. And then people go, why did I even get this thing? Because I thought I could do each room. And then I have to add up the capacity and I have to put the size unit outside that matches. And typically, the higher the capacity of the system, the higher the minimum modulation rate is. And so some of these, like a 36,000 might have a minimum modulation rate of 18,000 BTUs. And if I want to run just a 6,000, that means that refrigerant has to go somewhere. So it's going to start traveling into the next channel over. And that can cause problems like weird smells and weird sounds and just wasting energy. These bigger systems that match these multi-zones also have lower efficiency ratings than the smaller systems do. So it's not untypical for these to be 16 or 17 SEER, where some of the small mid-static ducted systems we're doing are in the 20s, and they're actually going to be able to slow down, so they won't be running at capacity. If you have one of these in your house and you get a leak, your whole house is going down. If you take and put 2 of these in and make them marginally smaller and match them up to the zones, at least you've got some redundancy built in. And this is a really complicated installation, and it's expensive. I was talking to a lady the other day. She got a quote for 6 of these, and it was over $40,000. And we looked at the house, was only 1,300 square feet, and she can do a small ducted system in the attic and take care of everything for half that. Single zone ducted systems, the advantages are multiple rooms with one unit, smaller capacity than multi-zone. They're super quiet when you install these right. And you can see my guys carrying a very large return air duct up into the space where this system is going. The larger your returns, the quieter the systems are. You really have an opportunity to make these things to where they're almost inaudible. They're going to be discreet because they're out of the living space. So they're going to appeal to those people with better aesthetics. So if you're going in behind somebody on another quote and they want to put a bunch of units on the wall, just talk about how I wouldn't have one of those on my wall. You should put a ducted unit in. The disadvantage is the insulation's a little bit more involved, as you're going to have a load calc to do one, and you got to just mind your P's and Q's when you're installing it. This cannot be slapped in. It takes a little bit longer to install. Here's some one room options that are pretty cool. This is I saw one of these that was just the opposite of this at Costco the other day, and it was $400. And the air side goes inside the room, and the window shuts all the way down on it. And the outside unit was outside the room. So the noisemaker is outside the room, all the water drainage and everything is outside the room, just like a typical window unit, except you're able to shut your windows, which is pretty cool. I like these a little better when they kind of hang down because they don't impede your view. These gradient units are really nice. There's a couple of other brands building these right now. Then we have the European versions. Europeans always do some stuff so like elegantly, right? This European unit, just has a air intake and exhaust that go outside, and all of the components for the entire heat pump are just in this box. This is the same way. And so compressor, coils, fan, water management, everything is inside this box. These typically are in the range of about 10,000 BTUs per room. There's not a lot of choices in capacity, but they are inverters, so they do slow down a little bit. And then you could also do the portable unit if you wanted to do that. So do we need furnace backup or resistance backup with a heat pump? We don't if we install the right one, especially in the climate that y'all are in the Tri-County area, anybody outside of that, but really unless we're up in snow country, Big Bear or the Sierras, we don't need backup heat on these machines. So if you're going out and selling traditional single speed heat pumps with backup heat, you're doing the customer a disservice because these units are not going to perform that well and they're not going to save energy. So we don't really need this in California. So do a load calc and figure that part out. Great air to water solutions out there. This is probably the next place where Electrify My Home is going to go as far as technology. There's some restrictions to what we can do with the new refrigerant in some of the manufacturer's products. And so it might become that running water pipes through the house is going to be easier than running refrigerant pipes through the house. And we can put these systems in that have multiple channels. They have a diverting piece. So you can do multiple heads, just like a mini split. You can do radiant heating, like a typical radiant house, or you can have a tank um, and an air handler and warm up the house with air that's generated during a certain time. So lots of opportunity with these units, and we're gonna crack the code on this one coming up next here. Partially because we've been really successful in installing these systems. This is called the Harvest Thermal. We've put a lot of these in this year. These use a small heat pump outside. This heat pump is optimized for when it's used. I'll show you that on the next slide. The heat pump heats the water in the water tank. The water tank is sized in such a way that you have 15% of the capacity of the water for domestic hot water, and the rest is going to be used to actually heat the house. Their thing that they do that's really cool is they run the heat pump, which is the mechanical portion, which is the part that costs the most to run. It's still not very much. But they run that and charge up the tank when energy is at its lowest price, concentrating on that period of time during the day when we have a lot of solar energy out on the grid. And then when it comes to peak time, all they're running is a very small pump and a fan motor. And so we're just running a fan motor and a small pump. That's a tiny, tiny little energy profile. So we're optimizing, we're load shifting from one time to another. These are beautiful systems. They're not inexpensive, but they do carry a 30% tax credit. So they are affordable once the incentives are redeemed. Then we have geothermal. I always have people that like read books on heat pumps come up to me at the expos and whatnot what we do and like, hey, will you install a geothermal? And then he shows me a picture of a house with a postage stamp size yard. And I'm saying it doesn't make sense to do geothermal in our mild California climates anyway because of the cost. But there's just most houses around here don't have a lot of space. You guys out on the coast out there, there's a lot of houses with a lot of space. It might pencil out, but we can do so much more with air to water than we can with these for the same amount of cost that it just makes sense to go with air to water in our climate. We have the air source and ground source heat pumps for radiant floors and swimming pools and hot tubs. We did a bringing back the natives tour the other day, and I put up a little table in front of a couple of my customers' houses. It's funny that people that love heat pumps also love native plants. So one of the customers I was at actually had one of these little Arctic heat pumps to heat their spa. And what she was telling me that it will heat her spa from 64 degrees to spa level temperature in a couple of hours, and it uses very little energy doing it. And I was pretty impressed by that. Now with a swimming pool, something like that, we have to kind of size that out, but there is opportunity for that as well. Um, so if you're really into the radiant and you're going to build a house and you want to design it in, there's these new solutions will work well with that. Doesn't work as good in retrofit when you're trying to work on a really old house. We have to be really careful about that because it's harder to deliver the BTUs. Here's a tale of two cities. This is in Amherst. The one city is Amherst, Massachusetts, and this is the Ross family into it. And in Massachusetts, they don't have the same solar energy radiation concentration as we do here in the Southwest. But they got enough panels up here to do the job for sure. And they put in this thing called a city multi-unit, which is very much a commercial system. And that city multi-system, actually, there was air handlers all throughout this house. So each zone had its own small air handler. So it was still designed to be very discreet, but they were able to take care of it with one unit. And this type of unit, the variable refrigerant flow systems, this is like a step above the currently easily available mini split level stuff. And I don't, these are also easily available, harder to install though. So they're great for certain applications when I need to do a lot of things in the house and kind of have all of them run at the same time. And some of these systems can even do heating and cooling simultaneously, but not all of them. So make sure you check first. Okay, we're good on time. Okay. So electric water heating products, heat pump water heaters. People are going to ask you. I had a customer ask me today. She says, we really want the electric tankless water heater. I'll tell you a little bit more about that in a second. But there are some alternatives. Mostly these are for people that didn't pay their gas bill. Um, there are some other ways to heat water, but the most efficient is going to be the heat pump water heater. So what these do is they have a small compressor in them that is about the same capacity as a double door refrigerator. The they use the refrigerant cycle to create a lot of pressure and heat. That pressure and heat is then put into the refrigerant. The refrigerant coils are wrapped around the outside of the tank under the skin. It exchanges its heat with the water, and then it comes back as a cool vapor, comes back up in here, does a few tricks, and then the heat from the ambient air is pulled into here, then compressed again, and it keeps just going and going and going and going. Very efficient way to heat water. When you do one of these, you have to be careful to design it properly and install it properly. Most of these are going to have secondary heating elements, and any of them that are available for the current iteration of incentive programs are also going to have to be um, user rate plan controllable or programmable. And basically what this machine will do is if it knows you're on a 4 to 9 rate plan where you're paying more for electricity between 4 and 9 p.m., this has got an automatic feature built into it that will get that water hot and ready for you at 4, and then it turns itself down to a much lower temperature between 4 and 9. So it won't go all the way off. If you use a lot of hot water, it will come back on. But the idea is to use that power during the day when power is cheap because of everybody's solar panels, and then use the water in the evening, which makes this thing into its own little thermal storage battery. A lot of them on the market. When we started installing heat pump water heaters, these two were really the only ones that were viable for the installs we did. Then this brand came out a few years ago with kind of a game-changing design. Um, and then now every manufacturer that makes any kind of gas water heater is now getting into the heat pump water heater market because they know that's not just where California, the sixth largest economy in the world, is going, but also where the entire country is going to go. So they have to build an offering for that. We're really excited about this model coming out later this year. This is the Navion. Um, it also has the duct connections on the top. Before this, the only unit we had for small spaces was one of these because we could easily duct it out. These units are going to be application specific in that they can't go into very small rooms unless you move the air to an adjacent space, and they're not always that easy to do. So, um, couple of nice ones here. This is the LG. That's a pretty thing. You knew that'd be from LG. It's gorgeous. There's a company called Kala, and these are a couple of engineers from a couple tech companies that wanted to disrupt the market. So what they did is they wrote an AI program. And so this one, as it runs, it figures out your usage patterns and it will better adapt to that. And this one also has an inverter compressor on it, so it can speed up and it can like turbo heat the water. So really nice technology there. General Electric is coming out with one later this year that is adaptable. It can be either 120 volt or 240 volts. And so you could theoretically install one really quickly off of what's nothing more than an extension cord, and then you can come back later and run the 220 volt power to it, and then it works as a hybrid mode. So it'll have the secondary heating elements after it's 220, but before it's 220, it'll just use the heat pump. We do recommend carrying more than one brand, dealing with a distributor that sells more than one brand of these because they are a bit application specific. These units that have side discharge fans, these are really not recommended for rooms under 700 cubic feet. When I duct one of these models and I put the duct in, I blow the cold air out and I suck air in from outside, I can have this in a zero clearance closet, which is kind of cool. These are not DIY. So if you're going to get into the business of selling heat pump water heaters, you're going to get that phone call, which is, I saw this thing over at Home Depot for $1,500. Why are you $7,000 to install this? And this is a good picture we tell our guys in the class to show. Like there is a whole lot of stuff here. This is not a DIY project for somebody unless they're pretty sharp, right? So um, steer people away from DIY installation of heat pump water heaters. It's really important. We got really used to. I got a cousin that I think could install a heat or a regular water heater, and my water heater goes bad. I send him to Home Depot, and he puts it in and doesn't run the flue right. But um, that's always been a nice, easy, cheap thing to do. It's not going to be moving forward. We have to talk to our customers about their lifestyle when we're selling one of these to the customer, and let them know these machines, because they have a fan and a compressor under here, like I showed you before, they are going to have a sound profile that people are not used to, and different machines, different configurations of machines have different decibel ratings, and these machines will actually make a different sound depending on what's going on. So even if they're at 45 decibels and they're running along, if the water comes in and it's really cold and the air is really cold, it will be a bit louder because the expansion valve will be wide open. So we want to talk to them about how quiet their lifestyle is. If you ask a customer and tell them, these make a particular sound you're not used to, how quiet is your lifestyle? And they trigger on that and they say, it's pretty quiet in here. Don't try to talk them into it and say, it's going to be fine. We want to talk to them about a different solution, which for us would be the Sandin or the Sandco. The Sandco systems, and this isn't really Sand CO2. This uses CO2 as a refrigerant. It's super quiet. Number one, because it's outside. Number two, because it's only 37 decibels. Um, these will heat 115 gallons of water for an 83-gallon system to 145 degrees. These units also have an inverter compressor, and since they're using CO2, it doesn't really matter how cold it is outside. They're still going to heat water, and they have the ability to speed up when it gets cooler outside or the water going through it is cooler, so it can adapt that. So it's always going to run a specific flow rate and a specific temperature of 145 coming out of this machine. Um, and if it can't hit that, it just ramps up or ramps down to get it. These are also 15 amp breaker in these systems, so we don't need a 30 amp breaker. They're going to recover just as fast as a traditional heat pump with strip heaters. These could be built, they can sit outside. As you see, these two are actually outside. The indoor tanks can go anywhere with no airflow needed, or you can really tuck them in anywhere that you can fit them. And you can cascade these systems. This is actually one outdoor unit that is heating water in two tanks for two separate apartments. And, people are willing to pay for this. If they want a heat pump water heater and they want to electrify, but they're scared of that noise in the house thing, this is the next thing that you might want to sell them. They look complicated to install, but I assure you they're not. The piping from here to the indoor unit or to the plumbing is all plumbing piping and not refrigerant piping. There's another brand coming out later on this year that we're going to start looking at the end of next month. I think we're going to get our trial unit, and it's more of a refrigerant based heat pump, and it has a line set that goes in, and it's got a condenser coil on the around the tank, and we hook it up with flare nuts or special fittings. Actually, they're pre-lined things, and they have a special patented fitting that you just clip on. So if anything ever happens to either end of it, you can unclip it really easily, keeps the refrigerant inside the system, and pop a new tank in, or pop a new line in, or pop a new outdoor unit in, whatever you need to do. The only disadvantage to this as being every man's heat pump water heater is they cost a lot. So a system like this right here, you're looking at about $16,000 installed. These something like this with a cascading tank and a whole bunch of plumbing and intricate installation, these can approach $30,000. So not every customer is willing to spend that much, but if they are, they are. Now this customer did not want to share water with the tenant that lived above her, and they were tenants in common. They both owned this old house that was made into duplex, and she lived downstairs knowing that if she heard the kids' feet walking to the bathroom, she knew that she wasn't going to get a warm shower. So she was insistent that they have separate tanks, and it worked out quite well. What about electric tankless? I get asked this all the time. Electric tankless is not a feasible option. A couple different reasons why. There's a huge capacity penalty. In other words, we need to run a lot of wires to this thing and a lot of power to it. For electricity to flash heat water, it takes a lot of BTUs, which means a lot of watts. And you can only buy these in certain sizes in California. And for a whole house heating load, for water heating load, the size system you get here isn't going to be able to do the job adequately. And it's insane. We would have to put a whole nother electrical panel in for this. This thing needs three 30-amp breakers to run it. So when we're electrifying houses, we're trying to conserve that space with good stewardship of the electric panel. This is not that. Okay. Electric panel products. So let's talk about electrical panels a little bit. This is an electric panel that has it's pretty full. Like there's no room to put anything. There's no more breakers will fit into here. And if I wanted just to put a heat pump water heater in, I would need a 30-amp breaker for a typical heat pump water heater. And so this is one of the ones we go over in our class. Like you can't do anything with these. These are arc fault breakers. You can't move these. I have heard that they are now doing tandem arc fault breakers, so they take up a little bit less space. But can't touch these. Can't touch the solar breaker. This one's already got a quad breaker in it, and these are already twinned out. So not a lot of opportunities to add power to this. So if I was going up to this on an electrification project, excuse me, if I was going up this on an electrification project, if I was just doing one thing like a heat pump water heater, I could do something very simple, like just put a quad breaker in here, take off another circuit. But then the next thing I need to do, I'm gonna be up against the same problem. So the way we look at all this is what can I do to future-proof these people's journey through electrification with what we have now? And so there's a couple different ways we might do that. Maybe we want to use something like a circuit splitter. Now, when you start electrifying houses, circuit splitters become very valuable. And this is one that we have a lot of them out there in the world. And basically what this does is it allows me to share a single circuit off of a dryer outlet or even a stove outlet, but I would watch that. And we have a primary output and a secondary output. And basically anytime the dryer isn't running, the secondary output will work. These are great if somebody wants a 30-amp car charger. Not great if they want a 50-amp car charger. We can also use one of these to share other circuits in the house if they're available. Like if they have a stove and a car charger now, maybe I want to take one of those breakers out of the system and run a switch here. These are a little bit higher amperage, and this is a hardwired solution, and it looks real small, but the thing's about that big. And these you would run one wire to, and then you run a primary circuit out and a secondary circuit out. And then as soon as you stop using your primary circuit for 5 minutes, it'll open up power to both circuits, and the next one that take load gets precedent. So the they work really well. This is most likely what we would do in a case like this is I would do a load calculation on the panel, figure out what we have available, and then I would run a wire sized adequately to take all the power out of the panel that we can under whatever the load is and run it to a sub panel. And then I can add multiple appliances into this sub panel off of one breaker. If you have an energy monitoring system inside of here, that's going to break. You're going to have to put another one in here potentially if they want to look granularly at their loads. But sub panels is what we would default to in a case like this if it's possible. And we had a job recently. We ended up putting a smart panel in, but we were going to do a to the dryer and the car charger, and we were going to bring the wire out that goes to the stove and go through a splitter and then run the splitter to the sub panel that had two loads on it. And that would work fine, but we got in there and figured out you couldn't put the CTs on, so we ended up going another route. This is another solution. This is called a circuit pauser, and this still uses that same technology, the simple switch, but you have to integrate these current transformers. And the current transformers are just going to be snapped around the hot wires, and you can see like they're pretty big. So we got to be cautious about these. This manufacturer also builds these current transformers that are smaller. So, but what the circuit pauser allows us to do is put a whole circuit on that will run when you need it, as long as power is available, and we don't have to use we don't have to put it on the load calc at all. Okay. So the other thing we could do is smart panels. I have one of these spans in my house. The thing's amazing. It's a complete energy management system for your house. You can load it up with 150 amps of power. You can put a car charger in it, and it'll figure out what it needs to do. It'll never go over a preset limit of power that you have programmed into it from the get-go. And so it'll keep you from ever going over just by not letting you turn certain things on. In my house, if my house gets too high, it'll modulate down the car charger, and it'll turn off. It won't let me turn on the dryer if I ever get up that high. But I have a total electric house, and everything is electric, and we're not super conservative about it because our bills are almost nothing every year. And so I don't really worry about that. And I've still never gone over like 8.5 kilowatts in my house. Sub-circuit energy monitoring. These are a good thing if you're going to be talking to people about electrification. Put one of these on your own house and show that to the customer when you go out and talk to them. So you can say, look, this is how energy management works. And then get some of these things installed out there. We've installed a ton of these Emporia systems. However, you have to clamp these around all the wires in the panel, so it does take up a fair amount of space. So chances are you're not going to get one of these jammed into a single wide panel, especially if there's lots of wiring in there. Okay, good on time here. Okay. So here's some other electrification products that are kind of interesting. This is where we're getting away from the heat pump part of it and how we're going to do the heat pumps. Remember, heat pumps are the heart of the system. Or I didn't tell you that. We consider heat pumps to be the heart of the electrification system, and we can make adjustments on what heat pumps we install and what we do to allow space for other things to come in. So here's some kind of cool stuff. I love these products in here. And by the way, some of these products we're showing you today are courtesy of Redwood Energy, and he is joyfully allowed us to share some of his artwork here. So something most people don't know, and we ask this in our classes, like, who has a gas stove? And some people say, oh, I love my gas stove. And I'm like, well, you have an intimate relationship with the fuel you're using to cook your food. That's that's something. But what people don't know is that gas stoves are only 40% of the stoves in the United States. The other 60% are already electric. So a lot of people in the country are living with them, and a lot of people out here say we can't live without them. Why would anybody not want to have them? So there's a couple of different types that we can use. We can use electric resistance, and these are going to show up in a couple different types, like the glass covered ones where we have the electric resistance heater under the glass and it's transferring actual heat to the bottom of the pot. Then we've got the ones with the old mosquito coil looking things, the coils that glow red hot at the top. Typically, these units are going to take a long time or a little bit more time. When you turn down the temperature of the burner is still going to be holding a lot of heat because it's heating with heat. The best choice for this is going to be electric induction. Electric induction does not use heat at the source. It uses a magnetic coil, and the magnetic coil will sense the size of the pot. And some of these you can use a small pot or a larger pot, and it'll automatically sense it. And then you always have your power burner that does the workhorse of the cooktop. And we've seen these with 5 and even 6, and one with a warming thing in the middle of it. So that's kind of cool. But it just uses magnets, and the magnetic energy goes into the bottom of the pan, and the pan actually gets hot because the molecules in the pan can't move very fast and they don't conduct energy very well. So they just create heat. So what we're doing with these is we're just heating the pan up. And because these things can change their frequency really quickly when you adjust the knob, we can go from a rolling boil down to a simmer without having to wait. And we can go up to a rolling boil and sometimes within a couple of minutes versus a gas stove that might take, 6 or 7 minutes. So electric induction is the way to go. These also come in these little portable pods. If you're not aware of those, you can order one for about $60 on Amazon. I haven't looked at the price recently, so it might have gone up a bit. But get one of those pods. I believe 3C RIN actually has a lending program. If not, Southern California Edison does. The cost on these is not bad, and some of this has really come down. So, we got the Amana up here with the double oven. That thing's $1,800. That's not a low cost system, but excuse me. Are these watts up here? So we have them as low. These are regular electric ranges. So this is going to be the watts of the large burners. And so we can get into a regular electric stove for like under $500. We start getting into the induction stuff and it gets a little bit more expensive. I know Frigidaire has this one out there. A lot of our customers have this. This is a really nice range, and it's right around $1,000. The good LG, I have one of these LGs in my house. This thing is really great stove as well. I love how the knobs are in the front, and it's knobs and not push buttons, because like one less thing you think is going to go out. But really, really nice clean surface. It still looks new after 3 years. It's brilliant. It's about $1,900. The gallery model, that's kind of more of a level slide in, with a little different controllers on, a couple $1,000. And then we get all the way down to these like retro luxury models that look like old, they look like an old Wedgwood stove or something, and they'll meet your beautiful your customers' beautiful kitchens, and they can get pretty pricey. Like this one right here, this AGA Classic is $22,000. So there's a lot of choices in all of this. So choose wisely. Oh, for all the Swifties out there, your girl Taylor Swift, she actually cooks on induction. So that's just another reason why she writes songs about all of her breakups. Maybe all of her boyfriends loved gas stoves. I don't know. Maybe that's what it was. I have no idea. But it's kind of cool to see these to see like influencers and people actually adopting this stuff and getting the word out. It's really important that we do that. And thought it was kind of cute that she has the "You Belong With Me" song about her induction range. Well, that's really cute. Lots of cooktops as well. So these are just cooktops and not total ranges. So if you got the separate oven and cooktop, lots of opportunities for those too. I was searching for one of these for a customer the other day, and just a couple of years ago, I did the same search for a different customer. I came up with about 10 options. This one, there was so many options that would fit. I had to send him over a link and tell him to find the one he wanted. This is too hard for me to do shopping for him. But lots of that technology coming out there too. So if you got the gas cooktop and you need to put and you want to put the induction in, you're not left out of the game there. We even have battery powered ones. So these are really cool. We had an event in our office last week, and we were demonstrating this unit. This is called the Copper Charlie, they call it, but it's designed by a company called Channing Street Copper, real close to us. And basically, it has a big giant battery in the bottom of it. And in case it's going to be difficult to run a 50 amp wire over to the stove, this thing plugs right into 120 volts. Couple of benefits from that is when you're cooking during peak rate hour, you're never using more than what your pigtail will bring you. And ultimately you could cook with the thing unplugged. So like if you want to optimize your energy use during peak rate, which is when we all cook dinner between 4 and 9, I won't say all because maybe some people eat at 10 o'clock. I don't know. It's going to give you that flexibility. The other thing that I hear from customers is, how am I going to cook if the power goes out? Well, here's your answer, right? These things will cook with the power completely off. They said that you could cook a meal for 50 people on this on one battery charge. So, and if you keep it plugged in, it's gonna when you're done cooking, it's gonna start charging back up again with just the amount of power that comes from a regular old plug. So amazing, amazing, amazing technology. And interestingly enough, they started by converting a bunch of LG ranges to this technology before they built their own. They definitely took a step up in their manufacturing and the way that these units look. And it looks good in the picture, but it's even more impressive in person. And not to be left out, just so we know, it's not in the slides, there's also battery integrated cooktops. So if you can't get that wire over to that cooktop, or you're at the end of the end of your capacity, you can also get a battery backup cooktop that also uses 120 volts to recharge it. But why would we want to get an electric stove? I love my gas stove, Larry. Why would I want to go electric? It just doesn't make sense. We've had gas ranges for a really long time. People have gotten really used to them. They're really great, like if you got a walk or something going. But now we even have induction walk bases. So there's no more excuses there. The reason why we want to go electric now is not just because we want to electrify everything in the house, but the same reason why we are is to have better, cleaner, more healthy air. And what we found, because we didn't always have $120 monitors that we could stick on the counter and see what the air quality was in the house, we now can do that. And so we can now see what kind of nasty chemicals are coming out of our gas stoves. If you think about it, your gas water heater has a flue pipe, your gas furnace has a flue pipe, your gas stove flue pipe is that hood that nobody ever turns on. So if you guys, here's something to think about. If you guys cook with gas, anybody in the audience cooks with gas, run that stove hood while you're running that so you can get some of these chemicals out of the house. And just remember, those stove hoods don't work that well. But so this is they're looking at a gas stove through an infrared camera. And this is not all flame. This is the heat signature and the plume of kind of exhaust that's coming out of a single burner as they're cooking on it. And what's in that exhaust is one of these nasty little chemicals called nitrogen dioxide, which is really what they want to reduce everywhere. It's the NOx rating. And so nitrogen dioxide, if you lived next door to a gas power plant, the federal requirement for air quality would be you couldn't go over 100 parts per billion outside with nitrogen dioxide. However, when you cook one dish on an on a gas stove in your house, you can get between 13, and maybe that's if you're just warming up some ramen. But if you're cooking a real dinner, up to 190 parts per billion of this nasty little chemical right into your kitchen, which means right into your lungs and right into your kids' lungs. We don't want to do that anymore. We know what these things are capable of. We know that they're good to cook on. People like them. We also know that they're not good for your health. If you cook a full meal on a gas range, you could be bringing that parts per billion up to 420. And if you ever just are tired of not cleaning the oven and you say, I'm going to clean the oven one day, you could be putting 670 parts per billion of this nasty little nitrogen dioxide chemical into the air of the house. And compare that to electric. It's so much less with electric. So think about it that way. We have, we know that gas stoves pollute the air in the house, and we know that we have induction as an electric option that works so much better than gas. Why are we hesitant in changing? This is a technological upgrade for your house. Induction stoves are like cooking on a futuristic appliance. It's just another wonderful thing to put into your house. So anyway, okay. Outdoor entertaining and heating and barbecue. So we got those great things we hook our propane tank up to, and they just kind of spew some heat out into the patio. Well, we can now do that with, some kilowatts. So if you're really into like reducing your carbon footprint and you want to get some electric heating stuff outside, we have it. So these infrared heaters are really pretty awesome because they radiate heat towards you. They don't rely on convection. They're not blowing heat on you. They're radiating it towards you. So your body has 60% of what your body feels as temperature is radiant heat. So when we're driving the heat towards you, we're going to get much more heat in a smaller area than we will if we're like pushing it out there and trying to convect it towards you. Same with this one. This is a great one because it's an actual table for your patio, and so it sends the radiant heat right down on your legs where you're really cold usually, especially if you're doing something that's a little bit more of a formal affair. Or in the summertime when you got when your trunk's on and it gets a little cool outside, this is a great deal. Sit down, have a cocktail with your friends, turn on the heater that's in the table, and your friends are going to just be blown away by that. Anyway. All of these are radiant solutions. And then even prettier ones, the Bromic Platinum Collection, just in case one of these wasn't fancy enough for you, you can spend a lot more and get something that's a little prettier that does the same job. We can also do that with barbecuing now. And once again, we're using radiant, which is still the same with a flame. But when you're radiating the heat off of an electric element up to the bottom of your very expensive T-bone steak, and you're cooking it and you're searing it perfectly, and a little wind goes by, and you're cooking with gas, it will disrupt the flames and you'll disrupt that heat transfer mechanism. When we're using radiant electric, we don't have the flames aren't going to get moved around. Will some wind come through? Maybe, but you're still going to get that radiant cooking. Um, we've got them for if you want it on your boat. Probably a good idea not to be cooking with gas on your boat. Although when we go up to the Delta quite a bit, haven't in the last couple of years, but a lot of people have gas barbecues on their boat, and I'm going, okay, that is one beer bumping into the barbecue too close to for comfort for me. Great little countertop version in case you got that beautiful built-in kitchen in your backyard. Got the countertop version electric unit, and then the amazing, the Electrichef Emerald 24. Look at this beautiful thing. This is cooking with electricity. This is going to give you constant, perfect temperature. No more like I cook with briquettes, and it's really hard to get the briquettes at the exact right temperature and have them last long enough to do all the cooking I want to do. So they're always either too hot or too cold. These things dial in the temperature. You're there. Way better than gas. If you got a fireplace in your house and you just love ambiance, like people love lighting fires in their house and just putting carbon in the environment just so they can see a little flame over there. So if that's what you like to do, if your fireplace isn't heating your house and you just like the ambiance, we haven't forgotten about you. We've got some great systems here too. One of them is the Optimist. So a lot of these are using lights and different devices in there to kind of fake you out and look like a flame. But in my opinion, the Optimist is one of the nicer ones. It uses it has an atomizer. You fill the thing up with water, and it's got to be filtered water. They put the filtered water in there, and it atomizes it into a very, very, very fine mist. And then it's got these different color light bulbs. So as the mist rises up through there, it lights the mist up and it looks just like real fire. So if you're okay to psych yourself out and say, I still have the ambience of a fire, I just don't want to put carbon in the atmosphere anymore. This is for you, man. And look at these are only $5,000. That's not, wow. That's a lot of money. So maybe you want to go for the Nova Heat or over the freestanding the Aquafire or the Aquafire Light. I don't know. We have options. You could also just go down and get some of those little candles from Home Goods that you put the battery in, and you get a bunch of those in a bunch of different sizes, and set those inside of your fireplace and turn all those on, and you get the beautiful ambient light from the fireplace. And all you got to do is remember to turn them off before you go to bed so you don't wear the batteries out. Okay. So lots of options here. You're not limited. You're not limited by the desire for fake fire, my friends. We've got it here for you. Okay. So laundry. If you have a dryer that plugs into the wall, it's a 220-volt electric heating element dryer. Some of those things can take a lot of power, right? So wattage by laundry dryers versus 30-mile-per-hour EV charging. In other words, if I want to charge my car at a rate of 30 miles of charge in every hour, I could do that by switching and moving my power around, right? So I could use an electric dryer that has 7,200 that uses 7,200 watts, or I could get a heat pump dryer that only uses 1,800, or I can get a condensing dryer, and if if you don't really care when the drying's done, it uses even less power. But we can do these things, and this is part of that watt diet and good stewardship thing. If we make good choices, we can use the power somewhere else. Okay. So this is a condensing dryer, and basically it has a tiny little heating element. It moves the air across. It's got a capture condenser, which is just some metal surfaces. And as it warms the clothes up a little bit, the air gets very humid. It dries through here. It condenses on the surface. It drains out, and then the dryer gets put back in here. And we're really condensing through a non-refrigeration process. But we've got that fixed for you guys too. We've got condensing washers and dryer combos. So these will do the condensing drying and wash your clothes, and pretty inexpensive. The beautiful thing about condensing dryers and heat pump dryers, which I'll show you next, are they're ventless. They don't need to be vented anywhere. So you could put them anywhere in your house and not worry about it. And up here, they have a little drawer that pulls out that captures the water that was in the clothes. You just empty that thing out, start over. So really, really cool technology. Very inexpensive here. You could get the condensing dryer, um, and you could get a 2.68 energy factor, or you can get a heat pump dryer and not even an efficient one, or excuse me, you could get the 3.0 energy factor, or you get a heat pump dryer and get even lower than that. So heat pump dryers are really the way to go. Here's the highest efficiency heat pump dryer. It's 10.14 pounds per kilowatt hour. So of moisture removal, which is insane, right? Annual energy use is about 236 kilowatt hours. That's not going to put a big dent in your kilowatt allocation for the year. So these are cool now too. This is a heat pump dryer with a washer combo. Probably if you're trucking around the Home Depot store and looking in the appliance section and you're a little bit curious, you've seen these. These are selling out there. My daughter actually bought one of these without any prodding from me. She said, "Hey, have you heard of these?" And I said, "Yeah, I should have told you about it." But she just learned about it by seeing it in the Home Depot, bought one, she loves it. Throw the laundry in, come back 2 hours later, it's washed and dried. It's a game changer, and you plug it into 120 volts and only pulls 11 amps. Amazing, amazing solution. A little bit more money, but man, it's awesome. Okay. So does it save compared to buying a regular $700 dryer and a $1,200 washer? It does. A combination washer dryer here, and let's look. The high end is about $1,600, and the low end's $800. This would be for a condensing model. A heat pump dryer going to be around $1,600. That's going to do a little better job, a little faster. And the condensing dryer down here is going to take a little longer, but it's a little cheaper. So, there's solutions for everyone. Okay. How about the best power outage solution in a big EV battery? So a lot of this is coming down the pike right now, and some of our manufacturing processes have kind of limited it, but a lot of the companies are working on bi-directional charging. They won't work with all the cars right now because it wasn't designed but there's a new protocol that's coming out where all the cars have to have this certain protocol. They should have done this 5 years ago, to where they'll actually be able to be utilized for that. So right now, one of the only ones on the market, but you also have to have the specific Ford Charger that has the inverter built into it. Um, that you can back power your house with your truck. Now I have a truck similar to this. It's not full electric, it's a hybrid, but it's got a power system on it that I can plug a 220-volt load into the back and it'll just run the engine and I could potentially power my house. We went camping one time and the power died in this little cabin we were in, and I rigged up an extension cord and everything, was able to run the extension or run the air conditioner in that thing. It's kind of cool. So the Decibel, the Wallbox Quasar, Nuve's coming out with one. Emporia's coming out with one. Enphase has one. Let them settle in for a year or so and work all the bugs out before you buy one. But that's just my advice to you as an electrification guy. Like snowmobiling, like outside sports, we haven't forgot about you either. So this is the coolest thing ever. Well, not ever. There are some cooler things, but this is pretty cool and it looks really cold. But this is a all electric snowmobile that makes no noise. Every time I've ever ridden a snowmobile, it was like, hey, that was fun, but geez, my ears hurt and the vibration, just all that. This is like a silent ride through the backcountry in the snow. The only thing is you want to know how far you can go on a charge and make sure that you turn around and go back the other way before you're halfway through your charge. Just some advice from the electrification guy. Same with the Tiaga jet skis. These guys make the same thing in jet skis. Also, I think he was saying 4 hours on a charge. You get 4 hours of riding on an 8 hour charge. So everybody I know that has a jet ski takes it to the beach, drinks beer all day, and rides it for 40 minutes. So if that's your deal, with this, you can ride up to 4 hours on one charge. If you're got one of those big yachts down there in the Santa Barbara Harbor, having one of these, you can just come back to the boat, plug the thing right in. Man, it'd be great. So got the Rambo hunting e-bike. We don't want to leave the hunters out of this. This is an e-bike that was specifically designed for like off-country use. And you can tell by the tires, it means business, but it has a really big motor in it. A lot of people they hurt themselves trying to pull the game out of the forest after they bagged their deer for the first time of the year and they forgot how out of shape they got between deer seasons. So this is going to save your heart. If this keeps you from having a heart attack, if you're a hunter, go for it. I'll never see one of these in real life. But this picture's kind of cool. This is something Rolls-Royce built a couple years ago. It's the 103EX with an artificial intelligence chauffeur. So you pop into this beautiful electric ride, you impress everybody on your way to wherever you're going, and the car drives you there, right? As far as I know, it might even serve you champagne. I'm not 100% sure. Then we have the Silent 120 motor yacht. If you've got it, you may as well use it, may as well spend it. This yacht actually runs everything off of solar and batteries. There's no combustion on this boat whatsoever. I heard that it has a gas range. Just kidding. So this unit, it does everything you need. I think this it could roll 500 miles a day based on the battery power and the solar on a full charge. I might be off on that number, but you can go really far, really quietly, really fast, and in amazing style. And just for, a few $1 million more, you can get this cool electric helicopter to go onto it. So, if you're looking, this is one to look at. This thing actually comes with its own electric personal submarine, just in case you drop the champagne over or you run out of battery on the boat and the refrigerator stops working, you need to cool the champagne. I don't think that's going to happen. There's a lot of power there. But you can go down, or you could just play like we used to play in the pool. We'd throw a penny down and go dive after it. This is like you just throw your champagne bottle down and go in your submarine and get it off the bottom of the ocean floor and bring it back up. Sounds like a great weekend to me. This is a cool thing. The Tamarack Golf Club or Tamarack Ski Club, they actually run their heat pumps, or they run their spa and their main pool off of heat pumps. In the wintertime, it's enough to keep these things super piping hot to where it's an enjoyable temperature in the hot tub. In the summertime, they run all the pools and all the supply water off of it. So the pool heat pump cut their bills in half from the actual carbon energy they were using. So win-win, and that was fun. Autonomous electric tractor. So electric tractor, you just tell it where to go with your app and it'll go, so got to imagine it doesn't smell good here. So maybe you stay in the office where the filters are good. Got some cool construction equipment that's all electric now, nice and silent, get it used everywhere. The world's fastest EV charger, 6 megawatts, is in development to charge the T264 3.2 megawatt hour battery in only 30 minutes. So these things will be running at a giant mine near you soon. And then we got the Ocean Bird 20. This is a ocean going vessel. It hauls cars. I think they designed it to, but it uses sail technology to boost it, and all electric. Electric airplanes. Now this one, I'm gonna have to wait for these to simmer for a couple years before I'm gonna jump on one. But electric airplanes, it's cool. Till you have to circle the airport. I don't know how that's gonna work. But there's a whole lot of electric stuff. It's not just limited to what you can do in your home. We're almost out of time here. I'm seeing the clock. I love this presentation because I love all these things. It's just amazing. So I hope you enjoyed that. And here you go.
Yeah, no, it's so great. I mean, it makes me really excited for the future, and it makes me wish I had endless funds to buy all this cool stuff for the home. But
Yeah, right.
uh yeah, but thank you for that, Larry. And just a few things to wrap it up. If you're looking for learning units, be sure to email me, or if you've registered with your learning units, I'll take care of it for you. This will be in your inbox soon. Like Larry mentioned, we have our upcoming heat pump zoning webinar, which will be a really, really great webinar. Some research that Alex and Larry have been doing and presented at the Dry Climate Forum this year. And then I just want to highlight that we have a couple of in-person trainings for folks in Santa Barbara. One about all electric ADUs, and one is a green building construction tour coming up in May and June. And then you can check our calendar for all of our other events. And I also just want to flag that we have all of Larry's webinars that he's done on demand. And so we had a really great one with electric panels last month. And so if you were, Larry mentioned it today, but if you want to get more in depth with that, you can get that on our 3C Run page. So with that, I'll wrap it up. And thank you so much to Larry, and thank you so much to everyone for coming out, and hope to see you at another webinar soon.
Thanks for spending your early evening with us.